Bismillahirrahmanirrahim. Assalamualaikum and hello everyone. I am Badrul Shahri Amri bin Abdul Khairul and my group Adrian Taipau, Shamil Shazwan, Afiq Shamim and Rusdi Chris will presenting about the petrographic and geochemical study of ultrabasic rocks in the vicinity of Ranau Sabah. So for introductions, our research provides crucial insight into the composition, origin and tectonic evolutions of this geologically significant formation. Ultrabasics, predominantly composed of peridotite and its serpentinized derivative, are typically associated with ophiolitic complex, representing fragment of the Earth's upper mantle and oceanic crust. In the Ranau region, these rocks are the part of the Sabah ophiolite belt, which has undergone complex tectonic process, including subduction, accretion, and abduction during the region's geodynamic history. Petrographic analysis focus on the mineralogical and textural characteristic, identifying primary minerals such as olivine, pyroxenes, and accessory chromite, along with the secondary serpentinite minerals from true hydration. Complementing this, geochemical studies investigate the elemental composition, including major, trace, and rare earth element to unravel the petrogenetic process and the mental source characteristic. Such studies provide a foundation for understanding mental dynamics, magmatic differentiation, and the regional tectonic evolution, offering broader implications for mineral exploration and geological mapping in Southeast Asia.
So for our research background, it's a study of ultrabasic rock in the vicinity of Ranau Sabah. It is pivotal in understanding the region geological history and the tectonic framework. These rocks, often linked to ophiolitic sequence, are remnants of oceanic lithosphere and mantle materials that have been emplaced onto the continental crust. During the past tectonic events in Sabah, the ultrabasic rocks are primarily associated with the Sabah ophiolite belt, which has been shaped by complex processes such as subduction, accretion, and abduction during the Mesozoic and Cenozoic era. The petrographic and geochemical characteristics of this rock provide essential information about their mineralogical composition, textural features, and chemical signatures, which in turn shed light on their formation and subsequent alteration process. Despite their significance, the ultrabasic rock in Ranau remains unexplored compared to other regions. Necessitating detailed research, such studies are critical for reconstructing the tectonic history of Sabah, understanding mantle process, and identifying potential mineral resources such as chromite, nickel, and platinum group element, common associated with ultrabasic rock. That's all for me.
Hello, I'm Shamil. I'm gonna talk about our objective. The primary objective of this study is to conduct a comprehensive petrographic and geochemical analysis of ultrabasic rocks in the vicinity of Ranau Sabah to elucidate their origin, evolution, and tectonic implication. Specifically, the research aims to identify and characterize the mineralogical and textural features of these rocks through detailed petrographic investigations. Additionally, geochemical analysis will be employed to determine their major, trace, and rare earth element compositions, providing insight into their petrogenetic process and mental source characteristic. This study also seeks to evaluate the extent of serpentinization and other alteration process that these rocks have undergone, contributing to a deeper understanding of their geological history. Ultimately, the findings will contribute to a broader understanding of the tectonic evolution of Sabah and its role within the regional geodynamic framework, while also exploring the potential for associated mineral resources.
The literature review for a petrographic and geochemical study of ultrabasic rocks in the vicinity of Ranau Sabah focused on the existing research on ophiolite ultrabasic rocks and the regional tectonics. The key areas of Focus include the first one is geological background. In the geological background, we review and study on the Sabah violet belt, including the tectonic setting, geological evolution, and the associated ultrabasic rocks. Key publication on the Southeast Asia of violet and tectonic provide context for runout ultrabasic rocks. The second one is petrography. In the petrography, we examining research on the mineralogical and textural characteristic of ultrabasic rocks, including peridotite and its serpentinite derivative. Study detailing primary minerals such as olivine and pyroxene and the secondary minerals such as serpentinite and talc. With petrographic analysis, the third one is geochemistry. In the geochemistry, analyzing past work on the geochemical properties of ultrabasic rocks, focusing on the major, trace, and the rare earth element composition. Comparative study from global group of violet complex help identify mental source characteristic and magnetic process. The fourth one is alteration process. In the alteration process, we exploring study on the serpentinite and hydrothermal alteration to understand post emplacement change in the ultrabasic rocks. This include literature on the fluid rock interaction on mineral transformation. The fifth one is regional study. In the fifth regional study, we investigating previous geological studies specific to Sabah, particularly to addressing the tectonic evolution of the region, emplacement, mechanism of ultrabasic rocks, and mineral exploration.
The geochemical analysis of ultrabasic rock from Danau Sabah reveals several key observations. The silica content is very low, ranging from 40.92% to 44.11%, confirming this rock are ultrabasic and likely formed from primitive metal-derived magmas. Both titanium oxide and phosphorus pentoxide levels are minimal, indicating limited accessory mineral. The rocks are rich in magnesium, which magnesium oxide content ranging from 29.78% to 38.55%, highlighting the presence of minerals like olivine and pyroxene. Calcium oxide is relatively high, up to 11.56%, pointing to calcic influence or possible alteration. Iron oxide are also significant, reflecting enrichment in ferromagnesium minerals. Trace elements like barium, cerium, uranium, and lead are below detection limit, while the rocks are highly enriched in nickel, which 2,831 to 14,705 parts per million, and chromium, which 2,502 to 3,205 parts per million, typicals of metal-derived materials. These geochemical traits suggest the rocks are from magnesium-rich pholitic magma, characteristic of ocean boson formed in tectonic setting, such as mid-ocean ridge or phyolite complex. The ultrabasic rocks are composed of unite and peridotite, which were created from low catalytic jet magma and its formation environment in the mid-ocean ridge, according to the petrographic and geochemical investigation. The stratigraphic sequence brought by Jacobson in 1970, which indicates that the rocks are intrusive, is consistent with this finding. Because ultrabase rock were created beneath the ocean during the Upper Cretaceous and are thought to be located along the mid-ocean ridge, ultrabase happened during that time. Middle Miocene faulting caused expansions and uplift. Hydrothermal actions on the ultrabasic rocks that form serpentinite and associated rock followed the late Miocene breakthrough of the Mount Kinabalu batholith and subsequent uplift in the Pleistocene epoch.